Hello everyone, so in this tutorial we're going to learn how to implement a multiplexer related circuit in Proteus. So this is our experiment. So in this experiment we're going to design and implement this circuit over here. Alright, so we can see that there are some muxes. There are about 4 muxes in this circuit. All of them are 2:1 muxes. Alright, so we can see the IC number of the mux here, 74153, and we'll also need an adder IC, which is numbered as 7483. Okay, so why do we need the adder? Because in this experiment we are going to add some numbers. Alright, we have 4 2-bit numbers A, B, C, D. Alright, and there are 2 selection variables. As we know that there are selection pins available in multiplexers. Alright, so so there will be 2 selection variables, S1 and S2, and based upon the input of those selection variables we're gonna do some addition operation. Alright, so whenever S1 and S2 both are 0, then we'll add A plus C. Okay, and when S1 is 0 and S2 is 1, we'll add A plus D, and S1 is 1, S2 is 0, then B plus C, and if both are 1, then we'll do the operation for B plus D. Alright, so this is the operation we're going to do at the end of the circuit. Okay, so at first let's just have a quick lesson about how multiplexers work. Okay, so in a very general sense, I'm just gonna draw a 2:1 multiplexer. Okay, so this is a 2:1 multiplexer. Let's put A here and B here. Alright, and since this is a 2:1 multiplexer, okay, 2:1 multiplexer, so there will be one output as usual. Multiplexers always have only one output. Okay, and there will be selection pins. So since there are 2 inputs, so there will only be one selection pin. Okay, let's mark it as S1. Okay, so this is a simple 2:1 multiplexer. So how does it work? So we have to put some value over there in the selection pin. Since there is only one selection pin, so there will be 2 possible combinations. Okay, so S1 could be 0 or 1. So if S1 is 0, then since there are 2 inputs only, so if S1 is 0, then it will try to select the first input. Okay, this is 0. This is 0 numbered input and this is 1 numbered input. So if S1 is 0, it will select A and we will get A in the output. Okay, however, if S1 is 1, in that case we'll get B. Okay, if S1 is 1, then we'll get B, and this B will be shown in the output. Okay, this is how a simple 2:1 mux works. Okay, so if we want to see a larger mask, okay, let's see a larger mask over here. So this is a 4:1 mux. Okay, so this is 0, okay, 1, and okay, sorry, so 2 and 3. Okay, so there will be 2 selection pins. Let's mark them as S1 and S2. Alright, so S1 and S2, and if I put values here, since there are 2 selection variables, so we can put 4 different combinations. So if we put 0 and 0, then it will select the very first line, since this indicates the 0th input, and we'll get 0 at the 0th line at the output. Okay, so if it's 0 and 1, then we'll get 1. If it's 1 0, then we'll get number 2 input in the output, and if it's 1 1, then we'll get 3 in the output. Okay, so this is how a simple 4:1 mux works. Okay, so This is a 4:1 mux. So now that we understand about simple multiplexers, so now let's go back to our actual experiment again. So in our experiment, we are going to use multiplexers, but in our experiment, the experiment is constructed in such a way that we have some type of limitations. In this experiment, we can't use 4:1 mux. Okay, sorry, we can't use a 2:1 mux. We can't use a 2:1 mux. We have to use a 4:1 mux. So but in this circuit we can see that there are only 2:1 muxes, right? So how can we build a 2:1 mux using a 4:1 mux? So let's do that. We have to build a 2:1 mux using a 4:1 mux. Okay, so how can we do that? So to do that, we have to do something very simple. So there are two selection pins. So what we are going to do, we're going to short those two selection pins. Okay, we are going to make them as one. Alright, so there are two selection pins, S1 and S2, and we are going to short those connections. Okay, so if we short them together, in that case, alright, so we were building a 2:1 mux using a 4:1 mux. Alright, so we need to short the connections of the selection variables S2 and S1. Okay, so they make only one selection pin right now. Okay, and if we put 0 over there, then we can see that we get 0 and 0 both in S2 and S1. Okay, so if we get 0 and 0, then we'll be able to select only the 0th input. Alright, and if we put 1 over here, then we'll get 1 and 1 in both S2 and S1. Alright, and in that case we'll be getting this third okay, 0 1 2 3, yeah, 3 numbered input over here. Okay, because 1 1 indicates 3. Alright, 1 1 indicates 3, so in that case we'll be getting this input in the output, but we'll never be able to select we'll never be able to put values in the selection pins in such a way that we can get these two inputs over in the output. Okay, these two inputs in the output. Okay, so since we will not be getting 1 and 2 in the output, so what we will do, we'll short them and connect them to the ground, since we'll never be getting those. Okay, that's it. That's how we can build a 2:1 mux using a 4:1 mux. You can check it right here that we are getting only two inputs here, 0 and 3. Okay, two inputs, because these two are connected to the ground, so these have actually no effect in this circuit. And for those two inputs, we have only one selection pins. Initially we had two selection pins, S2 and S1, but we connected them together, so they made only one selection pin. Okay, that's it. Alright, so now that we know how to build a 2:1 mux using a 4:1 mux, now we will try to we'll try to see the explanation behind this circuit. Okay, so I'm going to draw this whole circuit again. I'm going to draw this whole circuit again in this whiteboard over here, and then I'll try to explain how this circuit works. Okay, so I'm going to pause the video, draw this whole thing, and then come back to the video again. Alright, so we have drawn the circuit, which is shown here. Alright, we have not yet connected them, so now I'm going to demonstrate how this circuit works. Okay, so there are four numbers, A, B, C, and D. Alright, so A, for A we can write the number as A2, A1, right? For B, B2, B1. So I'm just gonna write them down. And for C, Here's C2, C1, and for D it will be D2 and D1. Okay, so that's it. So here we can see that our muxes are connected in such a way that in one mux we have A and B. In two of the muxes we have A and B, and in the other two muxes we have C and D. Alright, so these are shown as basically 2:1 muxes, because eventually even though we will be working with 4:1 muxes, but we'll be modifying those 4:1 muxes into 2:1 mux. Alright, so here we can see that the selection pins of the first mux here is S1, and the second mux is also S1. That's because we are basically going to short them together. Okay, we are basically going to short them together so they become one. So if we put 0 here, okay, if we put 0 here in these selection pins, all right, so in that case for the first mux over here we'll get A1, right, and for the second mux we'll get A2. all right, so that means if we put 0 in the selection pins we'll be getting A. all right, and for the third and fourth mux, if we connect both the selection pins here too, and if we put 0 here, then we'll get C1 from the third mux and C2 from the second mux. Now what we can understand from this circuit is that in the experiment we saw that if we put 0 and 0 in both S1 and S2, then the operation will be A plus C. That means we'll be selecting A and C. Okay, you can see a very good point from here is that whenever S1 is 0 we will be selecting A, whenever S1 is 1 we'll be selecting B, whenever S2 is 0 we'll be selecting C, and whenever S2 is 1 we'll be selecting D. And here we can see that if S1 is 0, then we can select the inputs containing A, alright, A1 and A2, and in the here if S2 is 0, then we can select the part containing C, right? So this is what is shown in this table too. If S1 and S2 both are 0, then we can select A and C respectively, right? And this is what we are following here. So let's see another example. Okay, so let's see another example. Okay, so let's say that we put 1 over here. So S1 is 1. If S1 is 1, then we can see that B should be selected, right? And we can see from here that if S1 is 1, then from the first mux we can get B1, and from the second one we can get B2. So yeah, B is selected, and from the third and fourth mux, if S2 is 1, alright, then we will get D1 and D2. That's it. So as you can see, if we put both 1 and 1, we should be getting B and D, and yeah, we are getting B and D. Okay, so now we can see that our circuit is constructed in such a way that it matches with the operation table shown here. Okay, so that's it. Okay, so now that we get the outputs, okay, now that we got the outputs, we're going to connect the outputs to our adder, because eventually we have to do some addition operation. Okay, so how can we connect that? So from the first two muxes, we'll be connecting the outputs to the first part of this parallel adder, and from the second two muxes we'll be connecting the output to the second part of this parallel adder. Okay, that's it. So since we won't be needing these inputs over here, A3 and A4 and B3 and B4, okay, so we will be connecting them to ground. Okay, we'll be connecting them to ground, and the initial carry C0 this should be 0, or you can also connect it to the ground. And for the output, since we are adding only 2-bit numbers with 2-bit numbers, so we should be getting at most a 3-bit output. Okay, so S3, S2 and S1, that's all we are gonna need for the output. Okay, we won't be needing S4, so we can just ignore that, or we can just connect it to the ground. Same goes for the final carryout, because in our case the final carryout will be S3, because we are only adding 2-bit numbers with 2-bit numbers, so we can only get a maximum of 3-bit numbers in the output. Okay, alright, so this is the whole circuit. So this is what is drawn over here. I have just demonstrated this whole operation in this circuit. Okay, so now I'm going to ask a question here, that why are the muxes constructed in such a way that we are connecting A and B, I mean 2 different variables in one mux? Why not A1 and A2, like something like this one? Okay, why not A1 and A2 over here, and okay, and yeah, B1 and B2 over here? Why didn't we do that? Okay, so let me just show you. So if this happens, okay, in that case, if S1 let's say S1 is 0, right? Let's say S1 is 0. In that case, what we'll get A1 from the first mux, and we'll get B1 from the second mux. And the problem is that we're getting 2 different variables from 2 different numbers, so we are not getting a whole number. The point was to if we select if we put 0 in S1, we should be getting the whole number of A. Alright, that means the both bits of A, meaning A1 and A2. But if we build the circuit in such a way, okay, in that case we would be getting A1 and B1, so we won't be getting a whole number. We won't be getting the whole number, neither A or nor B. We would be getting the partial numbers from both A and B. Okay, so the partial digits from both A and B. So that's why we're not building the muxes in such a way. We're building the muxes in this way. Okay, what I have shown previously, that we're connecting 2 variables in one muxes, 2 different variables in one muxes. All right, okay. So I also want to mention here one thing. That's even though I have drawn these muxes as 2:1 muxes, these are basically 4:1 muxes, but I have already explained previously that we'll be using 4:1 muxes, and we are going to short the selection pins. So since we short the selection pins, we won't be getting these middle 2 inputs. Okay, so this will be connected to the ground, so basically these have no effects whatsoever. Alright, so that's why I have just omitted them here, but when I will build the final circuit using mux IC in Proteus file, okay, in Proteus, in that case we will be connecting these inputs to the ground. Okay, so we'll connect anything that's not needed to the ground. Okay, so this is the whole operation, and now we're going to see the IC configuration here. Okay, this is the mux IC 74153. So this IC is a special IC of mux multiplexer. So this IC is built in such a way that there are 2 4:1 muxes connected to one IC. Okay, let me just show you. Okay, so you can see that there are 2 sides. Okay, 2C3, 2C2, 2C1, 2C0. So these are data inputs, and 1C3, 1C2, 1C1, 1C0. These are also data inputs. Okay, so this is 1 4:1 mux. You can see the output for those 4 inputs here, the number 7. So this is 1 4:1 mux, and this is another 4:1 mux. Here's the output 2Y, indicating the output for this part. Okay, so there are 2 4:1 mux connected to one mux IC. Okay, and the selection pins over here, A and B. Okay, those since there are 4:1 mux, so there will be 2 selection pins. So there are 2 selection pins here. We can see that A and B. However, those selection pins are common for both the muxes. That means this A and B work for both the muxes, for this side and this side too. Okay, so what we are seeing here is that we will be needing basically 2 IC of this type of mux. Okay, we will be needing 274153 ICs. Okay, and the first IC will, okay, so let me just show you by opening open board. Okay, so for the first part over here we'll be needing 1 IC, and for the second part over here we'll be needing another IC. So for the first part we'll connect the necessary selection pins together, and from the second part we'll do the same thing over again, and from the first part we'll be getting A and B, either A or B, and for the second part we'll be getting either C or D. Okay, so if we used 2:1 muxes, then we would have used 4:1 muxes, but we have some type of restrictions here. We can't use 2:1 muxes, we have to use 4:1 muxes, and we have to use this IC. So if this IC is built in such a way that it has 2 4:1 muxes, so basically we need to do some we need to connect some connections together. We need to short some connections just to make them to work like a 2:1 mux. Alright, so what we are going to do is that as I said previously, we are going to connect the selection pins together, because I have already explained that over there. Right, if we want to build a 2:1 mux using a 4:1 mux, we have to connect the selection pins together. So we have to connect the selection pins together. Okay, and if we connect the selection pins together, then if we put 0 over there, then from this side we'll be getting, okay, so let me just put some numbers over there so that we can understand what we're doing. Okay, so this is B2, okay, so let's just put A1 and B1 over here, A1 and B1, and we're going to put A2 and B2 over there. Alright, so if we connect the selection pins together, then if we put 0 over there, then it will select this 1C0 from this side, that means A1, and 2C0 from this side, that means A2. You can check right from here that we will never get these two, 1C2 and 1C1 and 2C2 and 2C1, because the selection pins are connected together. That means it will either be 0 0 or 1 1, so we'll never get 0 1 or 1 0, right? So that's why we will never be able to get 2C1 2C2 or 1C1 1C2. Okay, so if we put 0 over there, then it's indicating 0 0. That means we are getting 1C0 from this side, which is A1, and 2C0 from this side, which is A2. So we are getting basically the number A. Alright, and if we put 1 over there, then we are getting 1 1. So in that case we are going to select B1 or 1C3 from here, and 2C3 or B2 from there. That means B2. Alright, so this is for the first part. Okay, so this is for the first part, and from the second part we'll be using another mux. We'll be using another mux, just like the previous one, and in that case we'll also connect the selection pins together, and in that case this will be C1 and D1, and this will be C2 and D2. Alright, so in that case if we put 0 over there, then it will select 1C0 and 2C0, that means C, and if we put 1 over there, then it will select 1C3 and 2C3 or D. Alright, so that's how we are going to build the whole circuit in Proteus. Okay, So there are also some other connections such as VCC and ground. So VCC needs to be connected to the power, and ground should be connected to the ground terminal, and there are also two strobes, 2G and 1G. So these will be connected to ground, okay, to make the circuit work. Okay, so now that we understand how this IC is going to work, so we are going to build a we're going to build this whole thing in the Proteus file. Another thing, so after we get the expected outputs, desired outputs from these ICs, there will be two ICs, okay, so we might be getting A or B, and we might be getting C or D. Alright, so whatever we get, we need to do an addition operation between them, and to do that we're going to use adder IC, just like I have demonstrated a few moments ago. So we're going to need an adder IC. So this is the very basic parallel adder IC. So we'll connect the outputs to A2 A1 and B2 B1, and we'll get the outputs from this adder IC as sum 1, sum 2 and sum 3. Since we are adding only 2 bits with 2 bits, so we should be getting a max of 3 bits in the output. Okay, so let's just build this whole thing in Proteus. Okay, so Proteus, we're going to take 74153. This is a multiplexer, as we can see, and 7483, this is an 4-bit binary parallel adder. We are also going to take logic state and logic probe. Okay, so now that we have everything, we are going to build the circuit. So yeah, let's just zoom in over there. Okay, okay, alright, so we'll need 2 muxes, right, and we'll need an adder IC. Let's just put it here. Okay, so there will be logic states for the inputs. Okay, so what I'm gonna do, I'm just gonna put the necessary inputs and outputs over there, and I'm going to come back to the video once again. Alright, so I have put the necessary inputs and outputs here. I have not connected them. I'll connect them just right now. Okay, so okay, so this will be A, so I'll just write it down so that it becomes clear to everyone what I'm doing. So this is AB, and this is C and D. Okay, so these two indicates the inputs for A, that means A1 and A2, and this is B1 and B2, this is C1 and these are C1 and C2, and these are D1 and D2. Okay, so now I'm going to connect them. So as we have learned previously, so I'm going to connect it here. Okay, so this will go right there, and this right here, we are not going to connect it over there, because remember, in our circuit, okay, in our circuit, the very first marks over here, it indicates A1 and B1, not A1 and A2. Okay, I have explained the reason a few minutes ago. So that means the number A, one part goes into this mux and the other part goes into this mux, so two different muxes, two different parts. Alright, so what we're going to do, one part will go there and the other part will go there in the second part, in the second mux. Okay, sorry, I think I have just made a mistake. So one part will go there and the other part will go there. Okay, and for B, one part will go to the first mux Remember, this is the mux IC, and we have two 4:1 mux in two sides. Okay, just like this diagram over there. There are two sides, but in our case we have both of them in the same side. Okay, but it works the same way. Okay, and these are the selection pins. We are going to short them together and connect them to an input, and these are the strobes, and we will short them together and connect them to the ground. Same goes for the second mux. We'll connect the strobes to the ground, and we'll connect the selection pins and short them. And C, one part of C goes here and the other part of C goes here. Okay, and for D, one part of D goes there and the other part of D goes there. So just check it over here that we have connected these in such a way that means for A, both the inputs of A are connected to the 0th inputs for these muxes, right? That means if we were to select A, we just need to put 0 in the selection pins, and then from this part of the mux, this one will be selected. Okay, this one, and from the second part, this one will be selected. Okay, because we put 0, so it will select the 0th line from here and the 0th line from this mux too. So that means we'll get A. Okay, so, and if we put 1, then we'll get this part over there from the first mux, this one, and we'll get this part from there from the second mux. Alright, so we'll get B. So this is how this thing will work. So we have just connected them based upon this diagram or this diagram, whatever you say. Okay, so we have just connected this circuit based upon the diagram. Okay, and we have also connected this one. So now that we get the outputs, so we are going to connect the outputs to our parallel ladders. So this is quite very simple actually. So we're just going to use the first 2 bits for those parallel ladders, A2 and A1 and B2 and B1. Oh, another thing, so we're not going to need 1x1 or 1x2 or 2x1 and 2x2. Okay, so what we're going to do is that we're going to connect them to ground, because we are not going to we won't be needing them. Okay, since we have already connected both the selection pins together, so we can't get those inputs 1x1 or 1x2 or 2x1 2x2. That's not just possible. Okay, so same goes for this mux too. So just another short notes, whatever we don't need, we'll be connecting it to the ground. This is to avoid any kind of unwanted values. Okay, so that's it. Same goes for this one too. So we won't be needing these two, so we can just connect it to the ground. Okay, and this is the initial carry, and this initial carry should be 0 for parallel ladder. We have already learned that, so we can connect it to ground too. Ground means 0. All right, and the outputs, and we have connected the outputs. So now let's check something. Okay, so what I want to do is that I want to add some numbers. Okay, I want to add some numbers, so let's just do that. So first of all, let's run the simulation. Okay, so currently both the selection pins are selected as 0 and 0. So if okay, so this is S1 and this is S2. Let me just put the values over there so that we can understand it better. This is S1 and this is S2. So if both S1 and S2 are 0, then we should be getting A and C. So let's just check it over there. So S1 is 0, S2 is 0, so we should only get the values of A. So let's change the values. Let's check it for 1 1 and 1 1 over there. Okay, so if we put 1 1 and 1 1 and we add them together, that means we are adding 1 1 with 1 1, which gives us basically 110, because 11 means 3, so 3 plus 3 is 6, and 110 is the binary of 6. So we are actually getting the same thing. Okay, 110, S3 is MSB, so we are getting 110. So that means our circuit is working right. And you can check one thing over there, that yeah, since we put S1 is 0, so whatever you put in B, it has absolutely no effect in this circuit, because B is not going to be selected since we put 0 in S1. Okay, see over there, whatever you put, it doesn't change the value, doesn't change the output, because it's just not active at this point since we put 0 here. However, if we put 1 in S1, then we should be getting the value of B. Okay, let's just check it. So we put 1, and now if we change the value of B, we can see that the output is changing. So now 1 1 1 1 1, it gives us 6 just like before, but now we are adding B plus C, because we have given the value of S1 as 1 and S2 as 0. Okay, let's just show another example. Okay, so let's say we want to add B plus D. Okay, if we want to add B plus D, then we should be putting S1 as 1 and S2 as 1. Okay, so S1 should be 1 and S2 should be 1. So we are adding B plus D. See, 3 plus 3 is 6. So let's just try another example. Okay, we are not going to add 3 plus 3. Now we are going to add 3 plus 2. Alright, so yeah, okay, 3 plus 2. So we put 3 in B, 1 1, and we put 2 in D, 1 0. So 1 1 and 1 0. You can see if we would if we add 1 1 with 1 0, we are getting basically, sorry, we are getting basically 1 0 1. Alright, we're getting 101, and that's what we are seeing over there in the output. Okay, so that means this circuit is working. Okay, so and since we have selected S1 and S2 as 1, so that means A and C have absolutely no effect in this circuit or in the output. Okay, you can check it right there. Whatever we do, the value in the output doesn't change, right? So this is the whole circuit. So this is how we can build this circuit in Proteus, and we can add two 2-bit numbers using our desired selection variables and a parallel ladder. Okay, so you can check it however you want, whatever you want to do, what type of operation you want to do. You just put the values accordingly. You just put the values accordingly based upon this table, and then whatever you put in A, B, C or D, it will give an accurate output in the from the parallel ladder. Okay, so this is how we can build the circuit, and this is for this whole lab experiment. So thank you very much for watching.